Welcome back for our next session. Our session today is on scientific notation. Before we begin into scientific notation, first let's take a look at a couple of abbreviations that you guys are already very familiar with. You use these every day. LOL, laughing out loud, right? JK, just kidding. You've got to be kidding. Too good to be true. ASAP, as soon as possible. So, why do we use these abbreviations? We use them because it makes it a whole lot faster for us to text these abbreviations, and it saves a lot of space and time, right? Well, scientists also use abbreviated notation when they're writing numbers. If we say that the estimated number of atoms in a 154-pound human body is 7 with 12 zeros behind it, we can actually write that in a scientific notation. Okay, all those zeros, we could actually write that so that it's easier to understand and save space. Okay, the mass of an electron is all those zeros and then 9109 kg, kilograms. Well, how do we read these giant numbers? Okay, we've got it's so much easier and it would save so much space if we use scientific notation. A number is written in scientific notation when it is expressed as a product in the form of a times 10 to the nth power, where a is between or is 1 or could be greater than or equal to 1 but less than 10. That's your scientific notation. So if we have 4,200,000, we can move the decimal all the way over right after the 4. Since the decimal point moves 6 places to the left, then you would have 4.2 times 10 to the 6th power. Now, if we have 0.000067, then you'd have to move the decimal over the other direction. The decimal moves 5 places to the right. And then we would have 6.7 times 10 to the negative 5th power. So when you have to move your decimal over to the right, our power is going to be negative. But if we move it to the left, then your power is going to be positive. Let's take a look at some examples here first. Okay, so 29,500. I want to move that decimal 4 places from here over 1, 2, 3, 4 places to the left. And that's going to give me 2.95 times 10 to the 4th power. Now, let's suppose I want to take this number and convert this into scientific notation. Let's see, what do? We're going to move the decimal from here over 1, 2, 3, 4, 5, 6, 7, 8 places to the right. So remember, if we move to the right, your power over here is going to be negative. So it's 4.3 times 10 to the negative 8th power. You guys remember all of these from before, so let's keep moving along here. Okay, so 2.1 times 10 to the 5th power, and now we're going to go the opposite direction. This is scientific notation, but now we want to take this scientific notation and express it in standard notation. Then you move your decimal. You're basically going to multiply this all out. 2.1 times 10 to the 5th power. And you're going to move your decimal over 5 places from 2.1. 1, 2, 3, 4, 5. And your number is 210,000. That would be standard notation. Now, let's say we have 6.8 times 10 to the negative 6 power. Then we're going to express in standard notation. We move the decimal here 6 places to the left. Okay, so negative, just like our number line, the negative means to the left, positive means to the right side. And so here our number in standard notation is going to be 0.000068. Scientific notation, we have products, powers, and quotients that can be all calculated in scientific notation. Be sure to write the result of these calculations in the correct scientific notation. So you have to take a look carefully at what your number that is given, the information that's given, what form are those numbers, is that number in? And then you can rewrite that in scientific notation. Okay, so now we have, let's say we have two numbers in scientific notation, and we need to multiply them to find the product of something. Okay, and so now we've got the tens also raised to powers, and we've been working with that, base numbers that would have the same bases and raised to a specific power. And then we take the first term and multiply those together. Let's see what we've got. Okay, so we're going to group them together using our commutative property. Okay, 7.5 times 2. That is one grouping. Then we can group our powers of 10 together here. 10 to the negative 5th times 10 to the 3rd. Now we have 15, okay, because 7.5 times 2 is 15. And then here we simplify 10 to the negative 5th power times 10 to the 3rd gives us 10 to the negative 2 power. Negative 5 plus 3 gives us negative 2. Okay, but 15 is not between 1 and 10. So we need to rewrite that in the correct scientific notation. And we move our decimal over, and we get 1.5 times 10. We move it over one place, and that's going to be 10 to the 1st power times 10 to the negative 2 power here. Then now you can simplify this, and we get 1.5 times 10 to the negative 1 power. Our next example, let's say we have a scientific notation, a number in scientific notation that we have to square it. So that's the same, if you write it this way, 1.2 squared, 10 to the negative 4th power squared. And what does that give us? You have 1.44 now. 1.2 squared is 1.44. 10, you take the negative 4 times 2, and that gives us negative 8. And there's our final answer in scientific notation. Now let's say we're going to take two large numbers here, and we're going to divide them. So you can rewrite it in this format right here. And you have 2.4 divided by 6, and then 10 to the 7th power divided by 10 to the 2nd power, or 10 squared. You split those out so that you could see it better. Then you can do your division, and 2.4 divided by 6 is 0.4, right? And then 10 to the 7th divided by 10 to the 2nd, we basically subtract the powers, remember, from our quotients, okay? 7 minus 2, and that gives us 10 to the 5th power. But can we leave 0.4 the way it is? That's not between 1 and 10, is it? So we have to move this, or convert this back into our standard or scientific notation, proper scientific notation, move your decimal place over 1, okay? And then so that's going to be 10 to the times 10 to the negative 1 power. And then times, you leave this 10 to the 5th power. Now we can simplify the 10, and we get 10 to the 4th power. Before adding or subtracting numbers in scientific notation, we have to make sure that both numbers are expressed using the same power of 10. So let's take a look here. Okay, these numbers have the same power of 10. 10 to the 6, 10 to the 6. Now we can add these two numbers together. We have 2.3 plus 5, and then times 10 to the 6th power. So 2.3 plus 5 gives us 7.3, and then times 10 to the 6th power, and then that was our final answer. Sorry, moved that too quickly here for you guys. There you go. Okay, for our next example now, we're going to subtract. See what happens when we have to subtract our two scientific notation numbers here. 10 to the 5th and 10 to the 4th, that's not the same though. So now we have to change those so that they are the same. And so what they did here was we moved your decimal over 1 place so that this becomes 10 to the 5th power. That way we can keep the 10 to the 5th power the same. And then all you have to do now is subtract 5.4 and 0.47. And then, what do we have here? 5.4 minus 0.47, and then that's going to give us 4.93. And then we can keep 10 to the 5th power the same, and there you have it. And then this is your final answer. Now, here are all of these prefixes: tera, giga, mega, kilo, milo, or milli, micro, nano. You're probably familiar with these, many of these, for computer storage. You know, when we buy a new smartphone or the iPad or computer, we talk about how many gigabytes the phone is. Okay, how much memory they have, megabytes or gigabytes. If you buy an extra, you can buy an extra storage or flash drive for your computer, and you could have up to 1 or 2 terabytes. Well, each of those, their values are: terabyte is trillion, giga is billion, mega is million. And then here are the powers of 10 right here, what those mean. This would be a very helpful chart to help you as you continue with your problems when we do the homework problems here. And this chart is on in your textbook on page 340. Now,